Hello and welcome to this presentation on simultaneous equations. This is the second presentation in the series. In the first presentation we outlined the various processes for solving simultaneous equations using the elimination or the substitution techniques. In this presentation we're going to apply those techniques in the context of practical orientated problems. So here we'll be given questions in descriptive form. We'll have to extract the information, form the equations, and then solve using the appropriate techniques. It is assumed you've seen the previous introductory presentation to simultaneous equations before reviewing this presentation. Here are some tutorial questions related to worksheet 2. I've just extracted a few questions here, 9 to 12, from that worksheet. With these descriptive questions, what you have to do is to generate the equations by extracting information from the question, forming the simultaneous equations, and then going about solving them. Sometimes in some of the questions you might be asked to use the final solutions as well. Question 10, for example, asks you to use the solution that you found. If you feel you can attempt these questions without further assistance, I would encourage you to stop the presentation now and attempt these 4 questions. The answers are given in the brackets on the right hand side against each question, but if you require further assistance, then some of the questions are worked through on the following slides. So, tutorial questions for worksheet 2 here. Question 9. We're given 2 quantities labelled M and N, and we're told that they're connected by the formula that's given here, which is M is equal to A multiplied by N plus B, in which the A and the B terms are constants. So those are pure numbers, in other words. Given in the question that when N is equal to 3, M is equal to 6.5, and that when N is equal to 7, M is equal to 12.5. And we're asked to find the values of the constants A and B. So in this particular question we are not given explicitly the simultaneous equations, we have to actually derive them from the information given in the question. So the first thing to note is the equation given. We're told that the equations we've got to form must follow this format of M is equal to A multiplied by N plus B, where little a and little b are the constants we're trying to find. So from the question we know that when N is equal to 3, M is equal to 6.5. So we can write that as an equation under the heading of M is equal to AN plus B. So that could be 6.5 is equal to A times N. I could actually write that as 3A, put the numbers first, plus B. And that would be an equation. We can call that equation 1 if you want to, that we've generated from the information in the question. We're also informed from the question that when N is equal to 7, the M is equal to 12.5. So we can form another equation. This time it would be 12.5 is equal to 7A plus B. And I'll call that equation 2. Now what you notice in this particular equation is that the coefficients of the B are the same. They're both actually 1. We don't write the ones, but the ones are there. So we've no need to factor out the equation in this case. We can simply subtract one equation from the other, because the signs of the coefficients of B are both positive, so we subtract the equations and we'll eliminate B in this particular case, and we'll solve for A. So subtracting 6.5, take away the 12.5 will give us negative 6 on the left hand side, and subtract on the right hand side 3A, then we subtract the 7A will give us negative 4A. The B's obviously disappear. So rearranging the equation, A is simply equal to negative 6 divided by negative 4, so positive 1.5. As with the previous questions, we need to now back substitute to find the value of B. So back substitute A into, and I can choose which equation I want to use. I think I'll use equation 1. So 6.5 is equal to 3 multiplied by the A, which we now and there was 1.5, and we add to that little b. So solving that, we will find that little b is equal to 6.5 subtract 4.5, so little b is equal to 2. Basically we put the 1.5 value of a into equation 1 and evaluate it. 3 times 1.5 is 4.5, subtract that from both sides of the equation, we get the value of 2. And we can see from the answer to the question that's correct. Question 10 is another descriptive question. In an experiment to find the frictional force, F, between two metallic materials, when a load W is applied, the law connecting the two quantities was assumed to be of the form F is equal to mW plus B. From the experiment, it was found that when F is equal to 2.5, W is equal to 6, and when F was equal to 3.1, W is equal to 9. We've got to find the values of the M and the B, they're the constants, and also we've got to find the value of F, given that W is equal to 12. So in this particular question, it's very similar to question 9. We first of all got to generate the two simultaneous equations and solve for the constants, the M and the B in this case. And once we've found the constants and found the equation, we then are asked to use it by putting the value of W into the right hand side of the equation and finding the value of the friction force F. So again, taking information from the question, we're given the equation F is equal to M multiplied by W plus little b, where little m and little b are the constants we need to find. F is the friction force and W is the applied load. So again, reading the information from the question, that will allow us to generate an equation. So 2.5 is equal to m times W, I could write that as 6m, put the number first, plus b. And the second condition we're given, 3.1, is equal to 9m plus b. So as in the previous question, we can see the coefficient associated with the b is 1 again, so there's no need to factor any equations. We can simply subtract them and find the value of m. We'll eliminate b, find the value of m. So subtracting the equations, 2.5 subtract 3.1 is negative 0.6 on the left hand side, and then 6m take away our 9m is negative 3m. The b's obviously disappear. And so solving this equation by rearranging, dividing both sides by negative 3 in other words, we find that m is equal to negative 0.6, and that's divided by the negative 3. That equals to 0.2. No units are given here, so we can't put any units after the answer, but 0.2 is the value of m. So now to find the value of b, I need to back substitute. And I'm going to give these equations labels just to make it easier to reference. So I'm going to back substitute m into, and I'm going to use equation 1. So 2.5 is now equal to 6 multiplied by the m, and we just found the m is 0.2, and we add to that the b. Again, all I've done here is taken the 0.2 for the value of m and placed it into equation 1 appropriately. Rearranging that equation, in other words, subtracting 1.2 from both sides of the equation, b will equal to 2.5 minus the 1.2, that's the 6 times 0.2, and that gives me a value of 1.3. So this is the value of 1.2 we're subtracting from both sides of the equation to find b. And this question also wants us now to use the equation. We now have the equation for F equals mw plus b. Equation F is equal to the m, which we found is 0.2, so 0.2w, and then we add to that the b, and the b in this case is 1.3. So there's the equation we were asked to find. So this equation here has now been solved here, noting that the m is equal to 0.2 and b is equal to 1.3. And finally we're asked to use the equation to find F, the friction force, given, this is from the question, W is equal to 12, probably newtons, it doesn't actually say, but probably newtons there. So therefore F is equal to 0.2 multiplied by, in brackets, 12, and then we add the 1.3. Evaluating, 0.2 times 12 is going to be 2.4, add to the 1.3 and gives us 3.7. So 3.7, probably newtons, is the frictional force. So that's finding F given W. And again our answers match with the answer to the question. Question 11. In 1969, a machine shop team leader and 7 machinists earned together £130 per week. At the same time, 2 team leaders and 17 machinists earned together £308 per week. We're asked to find the earnings per week of the team leader and a machinist. So first of all, let's state some nomenclature, some symbols. Let's let T equals to a team leader, and let's let M equals to a machinist. You can call them X and Y if you prefer, but I'm going to call them T and M in the context of the question. So from the information given in the question, we'll be able to derive 2 equations here related to the team leader and machinist, and from that we'll be able to find their earnings per week in 1969. So from the question I can see that 1 team leader plus 7 machinists earned £130 per week. Also from the question I can see that 2 team leaders plus 17 machinists earned £308 in the week. I'll call this equation 1. I'll call this equation 2, just to give them a reference. If I'm going to solve these simultaneous equations using elimination, I need to make sure the coefficients of either the t or the m terms are the same. I can clearly see that we're multiplying equation 1 by 2 and leaving equation 2 the same. I'll be able to make the coefficients of the t term the same. They'll both be 2 in other words. So multiplying equation 1 by 2, I will get 2t plus 14m is equal to 260. Multiplying equation 2 by 1 remains the same then, that's 2t plus 17m is equal to 308. Now as the coefficients of the t term are both 2, the positive 2 in this case, we will subtract the equations to eliminate the t term. So 2t subtract 2t is 0, 14m subtract 17m is negative 3m. And on the right hand side of the equation, 216 with subtracting 308 is negative 48. Rearranging the equation, dividing both sides by negative 3, then m is equal to negative 48 divided by negative 3, and that will equal to positive £16. So the machinist in 1969 earned £16 a week. To find how much the team leader earned, we need to now substitute the value of m back into one of the original equations. I'm going to use equation 1 here. So back substitute m into, and I'm going to choose equation 1. My choice. You can use equation 2 if you want to. So basically t plus 7 multiplied by m, and m we're showing is 16, the previous calculation, that's equal to 130. What we've done there is put the value of 16 for m into the equation 1. Rearranging, t is equal to 130, subtract 7 times 16, 112. so that's equal to £18. So hence in 1969 a team leader earned £18 per week and a worker earned £16 per week. In question 12 we're asked to calculate the cost of ceiling rose installation and the cost of the plugs used. This is the building context here. For one installation, 8 ceiling roses and 6 plugs are required at a cost of £2. And for a second installation, 12 ceiling roses and 5 plugs were required at a cost of £2.20. We've got to find the cost of a ceiling rose and a plug. Just note for reference that a ceiling rose is a decorative element affixed to a ceiling from which a light fitting is often suspended. That's just the context of the question here. So now stating some nomenclature, we will let R is equal to a ceiling rose and P is equal to a plug. For reading the question, we've got 8 ceiling roses, so that's 8R plus 6 plugs, and that was a total cost of £2. For the next installation we have 12 ceiling roses plus 5 plugs, and that was a cost of £2.20. For reference I will call this equation 1 and this equation 2. So again, to solve this using elimination we need to make the coefficients of either the R or the P terms the same. I could do this by multiplying equation 1 by 1.5 here, because 1.5 multiplied by the 8 will give me 12, which is the coefficient for R in equation 2. So I think that's what I will do, multiply equation 1 by 1.5 and equation 2 I'll leave the same. So multiplying throughout by 1.5, equation 1 becomes 12R plus 9P is equal to 3, and equation 2 remains the same. Again, as the coefficients of the R terms have the same sign, both positive, we will subtract to solve the equation. So subtracting 12R, take away 12R is 0, 9 subtract 5 is 4, so that's 4P, and that's equal to 3 subtract 2.2 is 0.8. Divide both sides by 4, so P is equal to 0.8 divided by 4, which is equal to 0.2. To find the value of R we need to back substitute into one of the equations. To back substitute the value of P into, I'm going to choose equation 1 here. So 8 multiplied by R plus 6 multiplied by P, and P is 0.2. That's equal to 2. Again, we put the value of 0.2 for P into equation 1 for P. So 8R plus 1.2 is equal to 2. So therefore R is equal to 2 take away the 1.2, so that's 0.8, and that's all divided by 8, and that's equal to 0.1. Thus the cost of a ceiling rose and plug is 10p and 20p respectively. Don't forget when we worked out these values, these were in terms of pounds, so 0.1 of a pound is 10p and 0.2 of a pound is 20p. I'll leave you with a few more questions that have been extracted from worksheet 2, questions 26, 27 and 28. I'll let you look at them in your own time. Again, the answers are shown in the brackets on the right hand side. Notice a hint in the question for question 26 here. For questions 27 and 28 you could solve using the elimination method. Here is the bibliography used to help generate the presentation. I hope this has been of interest to you, and thank you for viewing.